Ancient India was a land of remarkable scientific thought, where the study of nature and the universe was deeply rooted in observation, logic, and philosophy. Long before the rise of modern physics, Indian scholars had already begun exploring the principles of motion, light, energy, and matter through practical tools and symbolic concepts. Among these, three of the most fascinating ideas, the bow, the wheel, and the study of optics, reflect how ancient Indian knowledge laid the foundation for physical sciences. The bow, known in Sanskrit as dhanush, was far more than a weapon. It represented an early understanding of mechanics and energy transformation. When an archer draws the bowstring, mechanical work is done to store potential energy in the bent limbs of the bow. Upon release, this energy converts to kinetic energy in the arrow, a perfect demonstration of the conservation and transformation of energy. Ancient Indian texts such as the Dana Veda, Mahabharata, and Ramayana describe bows of different materials, tensions, and sizes, hinting at a practical knowledge of elasticity, stress, and projectile motion. The tension required to draw Arjuna's bow Gandiva, for instance, suggests an understanding of material strength and mechanical limits. Even though these principles were never formalized as equations, they clearly embody the same physics studied today under the laws of elasticity and motion. The wheel, or chakra, is another profound symbol and scientific tool in ancient Indian thought. It represented not only physical rotation but also the cyclic nature of time and motion. The Rig Veda describes the cosmic wheel of order, or Rita Chakra, representing the repeating cycles of day and night, seasons, and planetary movement. This symbolic understanding evolved into mathematical and astronomical models in later centuries. Texts like the Surya Siddhanta and the works of Aryabhata in the 5th century CE gave the wheel a scientific identity, as a model for rotational dynamics and celestial motion. Aryabhata proposed that the Earth rotates on its own axis, and that the apparent movement of stars is due to this rotation, a revolutionary insight in the history of physics. He also used the wheel as an analogy for circular motion, discussing angular velocity and relative motion centuries before such terms were coined in Europe. Thus, the wheel in Indian physics was both a philosophical metaphor and a scientific representation of rotational energy and the cyclical rhythm of the universe. Moving from motion to light, ancient Indian thinkers also explored optics, or the study of vision and illumination. In the Vedic and Upanishadic literature, light, or jyoti, was seen as both a physical and spiritual principle, the essence that makes perception possible. The Vaisheshika Sutra, composed by the philosopher Kanada around the 2nd century BCE, described light as composed of extremely fine particles, an idea remarkably similar to the corpuscular theory of light later proposed by Newton. Kanada wrote that light consists of particles emitted in straight lines, spreading rapidly and interacting with matter to produce vision. Another philosophical school, the Nyaya, developed a complementary view, explaining that vision occurs when light from an object enters the eye, an early form of the intromission theory, which aligns closely with modern understanding. These debates reveal that ancient Indian scholars were already questioning how light travels, how images form, and how perception works. Further evidence of practical optical understanding appears in medical and technical texts. The Sushruta Samhita, a classical work on surgery and medicine, mentions the use of polished metal mirrors, or darpanas, for inspection and treatment. The very use of mirrors shows an awareness of reflection and image formation. Similarly, the Arthashastra, written by Kautilya, refers to different types of mirrors made of metals like copper and silver, showing that reflection was not only understood but engineered for practical use. Later, The Surya Siddhanta and Bhaskara II's Siddhanta Shiromani extended this knowledge into the study of light in astronomy. They discussed how light travels from the Sun to the Moon and Earth, and how its bending through different media explains phenomena like eclipses and refraction. These are early references to what we now call the laws of reflection, refraction, and light propagation. Taken together, the bow, the wheel, and optics illustrate how the roots of physical science were embedded in daily life and philosophical exploration. The bow demonstrated mechanics and energy transformation, the wheel symbolized rotation and motion, and optics explored light, vision, and the nature of perception. Though ancient Indian scholars did not express these ideas using mathematical formulas, their observations and reasoning were deeply scientific. They combined practical experimentation with profound conceptual thinking, blending physics with philosophy and technology with spirituality. In a world striving for sustainable and holistic science today, these early insights remind us that knowledge need not be divided between the material and the metaphysical. The scientific curiosity of ancient India, visible in the curve of a bow, the turn of a wheel, and the shimmer of light, continues to inspire modern understanding of physics and the universe itself.